Okay, I'd like to just do a little bit more revision with you guys, and I suppose this is more of the 10A stuff, but it's essential for everyone. It is quite the straightforward indice. I mean, indice as a topic can be quite big, but this one really, what we're doing today is really just a very, very small part of it, and hopefully it's just revision from Year 9. Okay, so let's have a look at this. H times h equals h squared, and I think I'm pretty comfortable that you guys are okay with this. The reason there's a 2 there is that we had 2 h's. So if I throw a third in there, h times h times h to the power of 3, because there's 3 of them. Now, what happens when it gets a bit more complicated and we start multiplying these together? Now, what we're really looking at here is we're looking at h times h multiplied by h. So it's a bit like multiplying these two together. Now, how many h's are there here? There's 5, so our answer ends up at h to the power of 5. Now, an easy mistake to make here is that you think, well, it's multiply, I'll just multiply these two numbers together. But when you write it out in full, you'll see that there is only 5. So although it's multiply, you actually add these numbers together. This can be confusing once we add a few extra things, but if you write it out, if you're ever unsure, just write it out in full and it makes a lot more sense. So just make sure you've got those examples down, or if you're watching this in class, just pause it so that everyone can get this down. Okay, I'm just going to move on. Okay. So, again, just a couple of worked examples. Y squared multiplied by y squared is equal to y to the power of 4. Now, this is just y times y, which is this bit, and then another y times y. So there's 4 of them. 2 plus 2 is equal to 4. Now, if we add an extra one, or a higher number, we get 4 y to the power of 4 multiplied by y squared. Again, if you're unsure, write it out in full, and you end up with y to the power of 6. Now, I'm going to add a bit more of a complication in this one. So what we've got out the front is coefficients. You can treat the y and the squared bit exactly the way that you did up here. In fact, it's the same as these two are the same, with the exception of the 2 and the 3. But when you come to dealing with the 2 and the 3, you do actually have to multiply them. So it's a bit like, you know, if I gave you 2y times 3y, you'd multiply the 2 and 3 together. So this is very crucial, really. If it's a coefficient out the front, it does get multiplied, but if it's an indice up the top, they get added together. I think it's worth taking a note or writing something that just makes sure that you've got a note to say what that rule is. So if it's a coefficient or if it's a number out the front, it still gets multiplied. If it's an indice, it just gets added. So, what I would like you guys to do is to have a go at these examples. Now, I've got answers on the next slide. When you get down here, or here, for example, just remember if there's nothing at the front, then it's really a 1. But I think you should pause this video and then have a go at each of them, and then I've got answers on the next slide that I'll talk you through. Okay, I'm just going to go on to the answer slide. So, y to the power of 5 multiplied by y squared is equal to y to the power of 7. So I've added the 5 and the 2. Easy. And the same there. So these are effectively the same, just so that you've got different numbers. Now, with this one, remember there's a 1 out the front. So the 4 gets multiplied by the 1, the invisible 1, and becomes 4. But these two add together. 4 plus 3, 7. 3 terms this time, but you still just add them. 4 plus 3 plus 3, 10. So we'll do the coefficients first. 2 times 1 times 3 is equal to 6. And then you've got to add the indices. 2, 4, and it's 1. So if there's nothing there, it's a 1, which equals 7. And finally, 1 times 2 times 3 times 4 is equal to 24. And then 4 plus 3 plus 2 plus 2 is equal to 11. Okay. Let's have a look also at factorisation, which is a related part of this. And I'll just give you an example about what we're talking about here. Once you have a look at this, and I've deliberately put the 4 and the 2 into red, what I want to do is I actually want to factorise this equation. And to do that, I want to find the highest common factor. Now, you can treat these separately. The coefficients, the red bits, think about that separately to the y's. Now, what's the highest number that goes into 4 and 2? Well, we're going to end up with 2. So I'm going to write that down first. So that bit's easy. Next, this is where it gets trickier and stuff we haven't done much before, is what's the highest factor that goes into the y's? What I can tell you here is that y squared goes into both of these. It's the highest. Now, y to the power of 3 does go into this, but it doesn't go into this. Y goes into both, but it's not the highest. So y squared. Now, you then need to throw in some brackets. And I guess the easiest way to think about this is, what do I need to multiply this by to get this answer? I've got to multiply this 2 bit by 2, and I've got to add on 3 y's. What do I need to multiply this by here to get this as an answer? Well, it's just itself, so it's just 1. Now, I've got another way of thinking about this. So this is the same question, because I think it does get a bit confusing when you're looking at it in this form at the top. I've written it out in full, so I've taken the indices away. Now, again, the red bit should be easy. We can see that 2 is the highest thing. You can see that there's 2 y's go into both of them. So I can sort of chop off 2 y's. So that's where we get 2 y's, which is this bit up here. Y. Now what's left over? Well, I still need to get this number here up to 4, and I've got 3 y's left over. This bit here is just itself. And then if I clean it up and put the indices back in, I actually get the same answer that I had up here. I'll give you 15 seconds to make sure you've got that down in your book. Both examples or both methods of looking at that same question. Okay, I'm going to move on. So, how could we go about factorising this? Start by looking at the numbers. What's the highest number that goes into both of these? Well, we're going to have 4. Now, what's the highest value for r that goes into both? So, r squared can go into both. If you think about this, if I wrote it out in full, it'd be r, there'd be 1 left over. What do I need to multiply this by here to get 8r cubed? 2r. and then what I need to multiply this by to get this, and I just get 3. So the other way of looking at it, 4-bit, oops, what have I done there? So the 4-bit's easier. RR goes into both of them, but we've still got to get it up to 8R, so that a little bit more gets added on, and then if I multiply this by 3 I'll get this, so the answers are the same. So I want you to have a go at factorising these 4. Remember that if there isn't any, it's a 1, and if you need to write it out in full, I'd suggest you do that. So I think you should pause the video and then have a go at them, because I've got answers on the next slide. Okay, so I'm just going to go on to the next slide. So the first one here, 5 goes into both 5 and 10, so that's the 5-bit, and D2 is as high as we go. That will go into both of them. Now to multiply them out, I need to multiply it by 1 to get the 5D squared. But to get this here up to 10D3, I need to multiply it by 2 and get another D in. Highest factor of 15 and 10 is 5. I've actually made a mistake on this one. So, I've copied it from the top. D to the power of 4 actually is the highest here. So the answer should be D to the power of 4. I'll just change it. So the answer should be D to the power of 4, like this, and then 3D, sorry, that should be 3D. So if we just have a look at that again, so 5 goes in, is the highest that goes into both 15 and 10. D4 goes into both of them, and if I multiply D4 by 3, I'll get this as an answer. And then 5D4 multiplied by 2D equals 10D5. So this is factorised. There's your answer for the next one, and the next one. So that's it for indices. There will be some questions in on this for 10A, the 10A part of the test, or the quiz I should say, on Saturday and Friday. So this is also on Moodle, so make sure if you need to go over it again, feel free to do so.